In this video, we're going to go over scientific notation. Now, we use this to write very large or very small numbers. And to be honest with you, you can use scientific notation for any number, all right? But traditionally, very large or very small numbers. Now, a number, so here's our definition here. So a number in scientific notation is expressed as the product, so we're multiplying, so as the product of a number greater than or equal to 1 and less than 10 and a power of 10. Okay, now we write this as P times 10 to the K, where K is an integer. All right, and I'm pretty sure you've seen scientific notation before, but if you haven't, like this would be a number that is written in scientific notation, something like 3.4 times 10 to the 6th, or let's do this one. We'll do 1.2 times 10 to the negative 15. All right, both of these are examples of scientific notation. And really, what is happening here is this. This part of the number, regardless of what it is, it places our decimal. All right? So if K is positive, it's a large number. And if K is negative, it's a very small number. All right? But it just tells me where to place the decimal. All right? So let's go ahead and let's look at some examples where we are taking regular numbers and we're converting them to scientific notation. Now remember, according to our definition, in order to put a number in scientific notation, it has to be in between 1 and less than 10. Okay? So if we look at 341, please note that the decimal is on the far right. So I'm going to move this 2 places to the left. By doing that, that gives me 3.41 times 10 to the second. So if I move to the left, it is a positive exponent, and I just label how many times I moved it. That's it. All right? Let's try another one here. So 3,478, decimals on the far right, 1, 2, 3 places to the left. So this is going to give me 3.478 times 10 to the third. On the other side of this, let's say I had something like this. 0.0000. I'm always using 3. Let's try 741. All right. Well, all we're going to do is move the decimal so that it forms a number in between 1 and less than 10. So 1, 2, 3, 4, 5. So this is going to be 7.41 times 10 to the negative 5. All right, so here's what we learned. When we convert a decimal number to scientific notation, So if we move our decimal to the left, it's going to be p times 10 to the k, where k is positive. All right? And then if we move the decimal to the right, it's still going to be p times 10 to the k, where, in this case, k is negative. All right? Now, what about the reverse? What if we want to convert 2.58 times 10 to the negative 5? Okay? To a decimal number. Well, in this scenario, here's what we know. We know from the previous example, or basically this definition up above, okay, that if our exponent is negative, that means we must have moved it to the right. So what I'm going to do is the exact opposite. I'm going to move this to the left 5 spots. So 2.58, 1, 2, 3, 4, 5. Here's my decimal, and I fill in with zeros. So 2.58 times 10 to the 5th is the same exact number as 0.0000258. All right, let's draw another one here. Let's convert 8.941 times 10 to the 8th to a decimal number. All right. So to do this, once again, we're going to write our number, and then we look at our exponent. Since that is a positive number, we know that we had to move to the left initially to get there. So we do the exact opposite now. We're going to move this to the right 8 spots. 1, 2, 3, 4, 5, 6, 7, 8. And then I just fill in with zeros. So 8.941 times 10 to the 8th is equal to 8941 with 5 zeros. 1, 2, 3, 4, 5. So it looks like it's 89 million. Oh, sorry, can't read. 894,100,000. All right. So what about doing calculations with scientific notation? Well, it's beautiful, actually. To be honest with you, it's very simple. All right. So let's say we had the following. And we'll start very simple. First, we're going to do 3 times 10 to the 9th multiplied by 2 times 10 to the negative 3. Well, if you remember from the previous videos, the commutative property of multiplication says, hey, if you're multiplying, order doesn't matter. So watch what I do here. Please note that I am multiplying all of these numbers. I mean, even if you read it, 3 times 10 to the 9th times 2 times 10 to the negative 3. So nobody says that you have to do it in that order. In other words, watch this. 3 times 2. Well, that's 6. Times 10 to the 9th times 10 to the 3rd. Well, according to rules for exponents, if the bases are the same, you add the exponents together. So 9 plus negative 3, or simply 9 minus 3, is 6. So this is 6 times 10 to the 6th. That's exactly what it is. In fact, I'd like to show you how to do this on your calculator. So let's get out our calculator again. All right, we're going to turn it on. Now, on your calculator, it's normally, if you're using a TI-84, it's normally above the number 7. So you got the number 7, and then above the number 7 is a comma, but in blue, you'll see a double E, okay? That is our times 10 button. So like, for example, 3 second comma button. See how I got that little E right there? 3E to the 9th is this number right here. Okay? Now, if I want to use calculations with this, all I have to do is say 3 e to the 9th times 2 e to the negative 3 gives me 6, what is this? 1, 2, 3, 6 million. But then if you convert that back into scientific notation, you're going to get 6 times 10 to the 6th. Now, there is a button on your calculator. It's the mode button. It's in the second column, top button, where if you click on mode, let me move my LCD screen over, you can actually tell your calculator, hey, go into scientific notation. And how do we do that? Across the first row right now, normal is blinking. If I moved it over to the right one, now it's in scientific notation. So I hit move it over one and hit enter. Now sign, the SCI is blinking. So if I go back to my original problem, 3 times 10 to the 9th times 2 times 10 to the negative 3, watch what happens. 6 e to the 6th, which is exactly what we have written here on the board. So the only thing you got to be aware of is just what mode your calculator is in, because your calculator, if it's in scientific notation, it will always do scientific notation. So if you don't want that, put it in normal and just convert. And that's going to be it for this video. It's a nice short one, so enjoy.